All right, so again, today's topic is change in arithmetic sequences and geometric sequences. So we talk about what a sequence is to begin with. A sequence is an ordered list of terms. It can be finite or infinite, which means it can stop or it can continue on in a pattern. And each listed item is called a term. So we could have a set that looks like what's there, 1, 2, 4, 8, ... This would be an example when it would look like if it was infinite. Or it could have just been 1, 2, 4, 8, and that's what it would look like if it was finite. So the ... means continue on in this pattern. When we graph these, and this is the biggest difference between a linear function and a arithmetic function, is that these are just points, whereas a linear function is a line. So when we graph linear, it would be a full line. If you graphed an arithmetic sequence, for example, it would literally just be dots. Like you'd have a dot over 1, a dot over 2, a dot over 4, like that. Then there are specific kinds of sequences, and we're going to focus on two, arithmetic and geometric. An arithmetic sequence is when the difference between consecutive terms are the same. So you are adding or subtracting the same number each time. That would be arithmetic. If I'm increasing by 2 or decreasing by 2 or increasing by 5 or decreasing by 5 each time, then that's called arithmetic. We call the terms A1, A2, A3, A4, and so on. AN would represent any term in your arithmetic sequence, or actually any term in your sequence. And D is called the common difference. So D is the difference between each of these terms. So for example, if my set was 2, 4, 6, 8, ... what's D? Positive 2, good. And if it went 8, 6, 4, 2, ... what's D? Negative 2, okay? So again, D, common difference, and it is what is being added or subtracted to the term to get the next one. We remember this a little bit? Yeah, like we just touch on geometric and arithmetic in algebra 2. Okay, so example 1 says to determine whether or not the sequence is arithmetic, and if it is, find the common difference. So obviously, they're not going to be so obvious all the time. You're going to do second minus first, third minus second, fourth minus third, and last minus fourth. So you have to make sure it is the same each time. Yep. So if I go 4.3 minus 3.7, I get 0.6. If I do 4.9 minus 4.3, I get 0.6. 5.5 minus 4.9, 0.6, and 6.1 minus 5.5, 0.6. So is it arithmetic? Yes. And what is my common difference? 0.6. Good. So if I could give you a tip, it'd be like find something easy, like 4.3 to 4.9 is an easy thing to find the difference between. Find a pair that's easy. And then you can kind of check it using the other ones. All right, one of the formulas you need to know is how to find the nth term of an arithmetic sequence. So finding any term of an arithmetic sequence uses this formula, which is AN, represents any term in that sequence, equals A1 plus D times N minus 1. That is also not a formula that is given on your AP exam. So when we compile our formulas, that's something that we will definitely add to it at the end, but you definitely need to know it for this.
Did we have to reset our calculator for the pre-calc AP exam? Oh, we didn't go.
Okay. All right. Example 2 says find a rule or equation for AN for the arithmetic sequence. So A gives you blatantly, here's A1 and here's D, figure out the equation. B gives you a series, so you're going to have to work for it a little bit. But for A, again, this is AN equals A1 plus D times N minus 1. And I have A1, so AN stays as AN. A1 is 100 plus a negative 8, means it's just going to be minus 8 times N minus 1. Now, this is a totally acceptable answer, so you could literally leave it like that. But it also might, if this was a multiple choice question, it might be distributed. So just know that both would work. If I distributed, I'd get 100 minus 8n plus 8, or 108 minus 8n. Or negative 8n plus 108. So any of those would work, okay?
So if we put any of those on the
Doesn't matter. Yep. And if it's multiple choice, obviously only one of them would be there. A lot of times they expand it when it's multiple choice. But now think about like how we're going to eventually link this to linear, right? That basically is y equals mx plus b. It's just got different variables. So linear and arithmetic pretty much overlap as far as points go, not the shape. Okay, so for b, I need a1 and I need d. Which one do you have? 4 is your a1. Now I got to find d, right? So pick any two pairs. 3 halves minus 4, negative 1 minus 3 halves, negative 7 halves minus a negative 1. Doesn't matter which one you pick. 3 halves minus 4 would be 3 halves minus 8 halves, which is negative 5 halves. And that's D. So AN equals 4 minus 5 halves and minus 1. And again, that answer is perfectly acceptable. If it was multiple choice and it was distributed, then I'd have to distribute here. I'd get 4 minus 5 halves and plus 5 halves. 4 becomes 8 halves, and I'd get negative 5 halves and plus 13 over 2. And the order there could be switched too, but again, either of those would be fine. Question so far? All right. Example 3 says 2 terms of the arithmetic sequence are given. Find the missing term. So first of all, this is where, again, it's always important to read your instructions because it tells you it's arithmetic. It could also tell you it's geometric. So you have to make sure you pay attention to what's what. So if it's arithmetic and I have 2 consecutive terms, I only have to subtract it. I could just do A2 minus A1. But what's different this time? Do you have consecutive terms? No. We have A1 and we have A4, okay? So there's a lot of different ways to do this, but here's one trick. If I write out AN, my equation, equals A1 plus D times N minus 1, this term and this term always match. So I can adjust this in any way I want to. I could say this is A2 plus D times N minus 2. I could say this is A3 plus D times N minus 3. So you can adjust it any way you want as long as the base on the term is the same as the term you're given on the right-hand side, okay? So those two will tell you how many times you have to jump from something to something, okay? So if I want to go from A1 to A4, there's a couple different ways to do it. One is literally subtract it and then divide by the number of jumps. So if I'm going from A1 to A2 to A3 to A4, how many times did I add D? 3 times. So I can literally do 17 minus 8 divided by 3. That's the easiest way to do it.
Couldn't you also just do interchange?
Yeah, that's basically what we did, right? We basically did 17 minus 8, which is f of the second one and f of the first one, over 4 minus 1, which is 3. It's the same thing. Yep. So this would become 9 over 3, and my change, or D, is 3. Does that part make sense? Okay. So now we found D. Now I can use what we did up here to find A8. I can either say A8 equals A1 plus D times N minus 1, or I could even use A4 in the place of A1. I could say A8 equals A4 plus D times N minus 4. You could use either one. So now I'll plug in my A1 is 8, my D is 3, and N minus 1, and N is, this time it's 8. 8 minus 1. So I get 8 plus 3 times 7, 8 plus 21, which is 29. I could have done the same thing with A4, so I could have done A8, because we're not always going to have A1. A4 plus D times N minus 4, and I would have done 17 plus 3 times, N is 8, minus 4, 17 plus 3 times 4, 17 plus 12, 29. So you can use multiple things to get the same answer.
How much time they got D?
The easiest way to do it, if it's arithmetic, this doesn't work if it's geometric. I'll teach you a different way. But you do the whatever numbers you're given, you're going to do the second one minus the first one over how many times we jumped. So the difference between 4 and 1. Does that make sense? Yeah. Okay. So like Isabel had said, it's rate of change. You're doing rate of change, just in an informal way. All right, now we're going to talk about geometric sequences. So geometric sequences are sequences in which you are multiplying the same thing each time. So they say the ratio of consecutive numbers are the same, but basically we are just taking it and multiplying it by the same thing each time. The way you find the common ratio is what we call the R, or what we're multiplying by each time. Is you would take second divided by first, or third divided by second, or fourth divided by third, so you go right over left when you're finding your common ratio, okay? But again, geometric, when consecutive number, or the ratio of the consecutive numbers are the same, or you are multiplying by the same number. And again, R, common ratio. So we know D is the difference, which is arithmetic, and R is the common ratio, which is geometric. Here's example 4. Determine whether or not the sequence is geometric. So for these, we would divide. I would do 12 divided by 3, which is what? 4. I would do 48 divided by 12, which is 4. And then obviously 192 is not as easy to divide, so I would literally take 48 and multiply it by 4 and see if I get 192. And you do. It has to work for all of those numbers, so make sure you check all of them. So the answer here is yes, and it didn't ask for it, but my R would have been 4. R could also be a negative 4, so if you see your signs change back and forth between positive and negative, your R could also be a negative value. All right, now go to B. B is 1 to 1/2 to 1/3 to 1/4. So I have to divide. 1/2 divided by 1 is obviously 1/2. 1/3 divided by 1/2 becomes 1/3 times 2, and that's 2/3. As soon as you get ones that don't match, just stop. You don't have to go any further. It is not geometric. Questions on that one? Okay, this one, now we need the first 5 terms of a sequence. And this is before we even have a formula. So the easiest way to do it is just take that term and multiply it times your R for 4 times, because I need 5 terms. So the first term they give you is going to be part of the first. And then I would do 1 times 1/2, so it would be 1/2. And then I do 1/2 times 1/2, so it's 1/4. And then I would do 4 times 1/2, so it's 1/8. And then I do 1/8 times 1/2, and it's 1/16. So one way to do it is find your equation, which we're going to talk about in a second, but the other is simply just to multiply it out. All right, now the second formula for finding a sequence is if it's geometric, and this is it. AN equals A1 times R to the n minus 1. Again, it will not be given to you, not on this test, not on your AP exam. So it's the second thing from this section that you definitely need to know. AN equals A1 times R minus R to the n minus 1. And then we're going to manipulate the heck out of this thing, but that's the base one. So example 2 says, find the formula for the nth term of a geometric sequence. Again, it's important that it's geometric. These are going to get mixed together. You have to know, is it arithmetic or is it geometric? Find the indicated term of the geometric sequence. So if it gave you like R or D, it'd be easy to know if it's geometric or arithmetic. But in a case like this, it just gives you the sequence. You got to pay attention.
Sorry, but did you say this will be on the AP?
The topic, yes. The equation, no. They give you nothing. You have no reference sheet whatsoever. Yep, your brain is your reference sheet. Okay, so it says, again, find the indicated term of the geometric sequence. So it gives you 3 terms and it wants the 7th term. So this would be my A1. This is obviously A2. This is A3. First thing you want to determine is what is r. How do I do that? Pick 2 and divide. So obviously I picked the smaller ones. 36 divided by 3 is 12. So r is 12. Then I can set up my equation. So an equals a1 times r to the n minus 1. So an would equal 3, because that's my a1, times r, which is 12, to the n minus 1. That will give you any term in your sequence. So if I want the 7th term, a7 would be 3 times 12 raised to the 7 minus 1, and I'd get 3 times 12 to the 6th. And a lot of times this would be on the non-calculator portion, and the answer will literally be left as that. Like if you look at your multiple choice, that would be an answer. Obviously, if it's on the calculator portion, you would multiply that out. But if it is on the multiple choice, without the calculator, it would be left as that. Now, what you don't want to do is 3 times 12 to the 6th, because then you're doing 36 to the 6th. You have to make sure that you're only raising 12 to the 6th and then multiplying it times 3. Does that make sense? That 6 only applies to the 12. So 12 to the 6th times 3, 8, 9, 5, 7, 9, 5, 2. So 8,957,952 will appear momentarily. Well, there was a hand over there. Was that you, Lauren? Okay. So without a calculator would be the first one. With a calculator would be the second one. Be prepared for either. All right. So now this is where it can get confusing. If you understand it, it's super easy. But if you're not paying attention, this is going to get really confusing. Because this is what happens if you jump terms and it's geometric. And they could give you, this time they give you, I could give you like the first term and the 4th term, but they could give you the 7th term and the 12th term, and you'd still have to know how to do it. And this, we can't use our rate of change like our slope, because these are not linear. So you cannot use them the same way. So I'll teach you a trick, and it's very easy once you understand it, but you got to pay attention, okay? So the first thing is that our equation, our an equals a1 times r to the n minus 1, okay? If you think about the relationship between these things, if I wanted to find, for example, if I wanted to find a2, this would be a1 times r to 2 minus 1, and that becomes a2 equals a1 r to the 1st, if I simplify it. I want you to watch for this pattern. If I wanted to find a3, it would be a1 times r to the 3 minus 1, and that becomes a1 times r to the 2nd. So in every single scenario, the exponent on the r plus the base on the initial term have to equal the base of what you're trying to find. So if I wanted to find the 10th term, I had the first one, then r has to be raised to what power? 9. If I wanted to find the 10th term and I had the 3rd term, what does r have to be raised to? 7. So those two always add up to what you're trying to find. Does that make sense? Okay. So if you're given the 1st term and the 4th term, I'm going to set up my equation. A4 would equal A1 times r to what power? The 3rd. And then I'm going to plug in what I know. I have A4. It's 1/2. I'm plugging in A1. It's -4. I don't know r, but I know it's raised to the 3rd power. Then I'm going to divide both sides by -4 or multiply by -1/4 over here. And I get r to the 3rd equals -1/8. And I cube root both sides.
What did it be -2? Because you keep changing it.
No, I already keep change flipped it. So dividing by 4 became multiplying by the 4th. And then what's the cube root of -1/8? -1/2. Good, right. No. It's because it's a cube root. Yeah. It won't give you something that's imaginary. It can be done. Okay, so now that just gave me the r. Now I want to find the 10th term. And I can use either to begin with. So for example, if I use A10 and I start with A1, r is going to be raised to what power? The 9th. If I wanted to find A10, but I started with A to the 4th, what would R have to be raised to? The 6th. So you can use either one. Does that make sense? Yes? Okay. So A10 would be A1 in this case, -4, times R, which is -1/2, raised to the 9th power. And again, without a calculator, it will actually keep it like that in your multiple choice selections, as long as it's like if it's a higher exponent. If that was something like -1 to the 3rd or -1 to the 4th, -1/2 to the 4th or something like that, then you would actually work it out. So if you did have to work it out, though, you would keep it in fraction form. So instead of finding -1/2 to the 9th, I just do 2 to the 9th, and I'm going to keep it as a fraction. So this would be -1/512. And then 4 goes into that because 512 divided by 4 is 128. And a negative times a negative makes it positive. So this is a positive 1/128. So without a calculator and with a calculator but kept exact is how that would be kept. You would not have decimals as your answers. So just be careful, make sure you know how to do both. And you can do the A10 equals A to the 4 or A4 times R to the 6 to check it if you had the time. And then you should get the same answer. Questions so far? All right, example 8. So similar concept, except I didn't give you A1 this time, right? But you have A2 and you have A5. So when I set up that initial equation, what does R have to be raised to? It's got to be the difference between those, right? A5, the bigger one's going on the left. So A5's going over here. A2's going over here, and R would be raised to? Nope. The 3rd. The difference between those two bases. Yeah. If you reverse it, you have a negative exponent. You could do it, but it's not going to be fun. So that's why I would keep it this way. So A5 is 2/3. A2 is -18. R to the 3rd. Divide by -18 or multiply by 1 over -18. Simplify. 2 goes into 18 9 times. This is -1/27 equals R to the 3rd. Cube root both sides. And the cube root of -127 is what? -1/3. And then I need this 6th term. So I kind of have 3 options here. I could do A6 equals A2 times R to what power? The 4th. I could do A6 equals A5 to what power? Times R to what power? The 1st. Or I have the 5th term. To get to the 6th term, I could simply just say 2/3 times -1/3, which is basically doing this without an equation. So I get -2/9. Questions on that one? All right, last up is example 9, and it says find an equation that gives the nth term of each sequence. Instead of using the initial value, use the k term of the sequence in your equation. So instead of using A1, we're using A of whatever the k is, okay? So the first thing you have to do is figure out, is this arithmetic or is this geometric? Because it doesn't tell you this time. So looking at A, what's happening here? Are you dividing by the same thing each time, or are you subtracting by the same thing each time? I mean, adding or subtracting, or or multiplying. You're subtracting 30 each time, which would make this what? Arithmetic. What is your D? -30, good. And instead of it, so it would be AN equals A1 plus D times N minus 1. That's your typical normal equation. And then I would plug in my A1, and then I would plug in D. What's weird this time, so that would have looked like this. AN equals 50 minus 30 times n minus 1. If it was just normal instructions and it said find the nth term, that would have been my answer. But it doesn't say that this time. It says use the kth term of the sequence in your equation. So instead of using A1, we have to use A2. So I'm going to say AN equals, what is A2? 20 minus 30 times n, and then what's true about what happens after the n? It has to match what? The base of this first one. So we did A2, which means this has to be minus 2. So those instructions say use the kth term in your sequence in your equation. So instead of using A1, we have to use what they tell you to use here. So I did AN equals A2 minus D times n minus 2. And then I plugged in for the A2 because we had it. And I plugged in for the D because we had that one. And it will either be left like this or it will be expanded out. AN equals 20 minus 30n plus 60. AN equals negative 30n plus 80. Yeah.
When it says use the kth term of the sequence in your equation, how do you know like where to put it?
It goes wherever your A1 was. And then it has to adjust whatever the minus, like n minus whatever, has to also get adjusted. Yeah. So if it had said, let's just say it said k equals 3, then it would be AN equals A3 plus D times n minus 3. And then I'd have to do A3, which is negative 10, minus 30 times n minus 3. And then I'd distribute it. Does that make sense? Because those instructions are weird, but that's what it's looking for. Okay, so now go to B. Are we adding or subtracting the same thing each time? No, we're doing what? We're multiplying this time. So this is geometric. And R is what? 2. So my initial equation is AN equals A1 times R to the n minus 1, typically. But I want that 1 to get replaced with what this time? 3. So it would be AN equals A3 times R to the n minus 3. And what is A3? 8, and my R was 2, and it would be n minus 3. If it had said k equals 4, what would it look like? 16, 2 to the n minus 4. Good. Those to me are the most confusing ones. Those and the ones where they jump. Like if you jump and it's geometric, that tends to be what hangs people up a little bit on this section. So be really careful. Questions? Okay. Yeah.